Oh, it's actually switched up. 1 second. There we go. All right. So, hello, everybody. Thank you very much for joining us. With the mission of accelerating the future of manufacturing, this company is enabling companies to create, iterate, and prototype faster by using the power of 3D printing. Let me introduce Makelab. Hello, everybody. Welcome to another episode of Builder Nation, the very first live episode of Builder Nation that is
Mhm.
not a panel. We had a panel in the past, but this is the first live interview we're doing. And today we're joined by Christina Perla, the CEO at Makelab. Christina, welcome. Thank you very much for being here with us today. Could you please introduce yourself a little bit?
Yes. Well, first off, thanks for having me. I'm honored that I'm the first guest of this new format. Love trying things out in true startup fashion. Love it. Um, so my background's actually in industrial design, but so it gives me a really unique perspective on the whole product design and development process and like what people's needs are. And that's what ultimately led me and my husband to creating Makelab. And so basically, we 3D print parts and prototypes for consumer and hardware brands that are making physical products. A lot of what we print, we end up seeing on the shelves, which is really fun. So we'll go to Target, we'll see, the bottle, the beauty packaging that we saw everything that we were like seeing in house months before it dropped to the public. And so that's always a fun part of the job.
Right. It does sound actually pretty fun seeing your work like displayed. It's amazing. I get the same feeling with the videos that we upload and everything. It's actually pretty cool. Thank you very
Yeah.
much for that brief intro. But before we get into the real saucy part of hardware and engineering and the whole thing, I want us to take a little step back. You already mentioned what sort of got you started, you and your husband, into this 3D printing world. But before that, I wanted to ask you more or less, how did you first discover, or how did you first learn that 3D printing was actually like this really amazing tool that could benefit the whole manufacturing industry? Because let's face it, before in the past, 3D printing was this sort of hobby for nerds like me, right, who will like building their own car blocks or their own Hot Wheels. So where was this point where you figured, hey, these might actually be useful for an industry?
So I was at Pratt in from 2010 to 2014. And so when I entered the industrial design program, there was like a single Stratasys FDM 3D printer in the lab where the laser cutter was. And so it was already starting to be used as a prototyping tool. Shapeways was also around. And so a lot of my classmates were sending like their final prototypes to be made by Shapeways for their finals, like presentations. So I always knew that it existed. I even got some stuff 3D printed myself, but I was always a little skeptical because I think, especially at Pratt, you're really taught on the curriculum of like, do everything the more manual way first to learn about it before you jump to the easier, like faster solution. So coming from that mindset, 3D printing honestly just seemed like too easy. It sounds dumb. I was so skeptical. I actually didn't like I sent something to Shapeways, but I didn't actually touch a 3D printer until like Makelab. So it was like quite a while after. Like I was
Okay.
such an old schooler. I was like, put me in a shop, give me a chunk of wood, I'll prototype, or like blue foam, whatever it may
Right.
be, I'll prototype that way. Um, but once I started to use 3D printing, I think that's when I was like, oh, I get it. This is what it's about. And really like my eyes opened at that point. And then from that point on, like I just never really turned back.
Right. Actually, that's a pretty cool way to see it. Like switching from that old school perspective or mindset into this no one. It's actually amazing. Now, I know that MakeLab is mainly focused on prototyping services and hardware for companies, but as a whole for 3D printing, how does it actually improve traditional manufacturing methods like already past prototypes, already manufacturing? How does it help?
I think it's interesting. I think it helps in a few different ways in a few different categories. So one is there's less mistakes made at the manufacturing process if you prototype more. And so because this tool is so available, it's so cost effective, you can even print a small batch of 1,000 to 10,000 parts. Um, it just leads to less mistakes when you do open up that mold and when you do enter a contract with a contract manufacturer. Um, the other thing too, there's another perspective to it, is on the manufacturing floor, a ton of custom jigs are made. And so
Mhm.
it's very possible that that time to create the mold itself and to create all the tooling is actually decreased because you have the availability of 3D printing. You don't have to machine. So that's another really cool aspect, but that I don't think is maybe talked about enough. Um, and then there's also the aspect of, well, it's kind of tied to point number one, in which, you could do a small test batch on your own using 3D printing if the material properties are right. And then you go to mass manufacturing where you're truly, truly, truly ready. Not only ready from a design and engineering perspective, but also ready from a logistics costing perspective as well. And so it just kind of, it adds another 3D printing. There's this whole dialogue and narrative that it's going to replace, or it was going to replace injection molding, but it's another
Mhm.
tool set. It's another tool that's available in the realm of manufacturing. And so you can leverage it in that way. Instead of an or situation, it's an and.
Now, actually, I wanted to ask you precisely about that difference. Now, you already mentioned injection molding. In injection molding, this was supposed to be the future of manufacturing, but now we have this so-called additive manufacturing, right? What are the main differences of these two techniques when it comes to prototyping specifically?
Well, the cost for prototyping and injection molding, I would assume, is really, really high. Every time you have to make a mold, that takes time. Stakes are higher because of that time. The time that you're waiting for this product to be made and that injection molding, that's only a few batches. That's time you could have been just quickly iterating and getting to a better solution. And so with additive manufacturing and all the different materials, technologies, and processes that you could leverage for your prototyping, it's so much more available and so much more
Mm.
wide. So you have a lot more choices. So, as a designer, we're really taught in the design process to like iterate quickly, fail quickly, learn quickly. And so just spit things out and like just try it out, test it out. I don't see really how that's possible with traditional manufacturing in a prototyping sense, but in a 3D
Mm-hmm.
printing sense, you can just quickly print out a part, even if it's not in your final materials. If you're testing for geometry or fit, even, you could test out something in the cheapest, most accessible material, and you can get your answers from that $20 prototype.
Right. Okay.
Yeah.
That's I didn't really expect that to be such a big difference. Thank you very much for
Oh,
for
yeah.
for that. Yeah, it's actually amazing. Now
Yes.
I wanna dive a little deeper into specifically this part of the prototyping, right? So for 3D printing already, you already mentioned that a lot of the main cost is also from materials, and you at Makelab actually provide options for tons of different materials. You even have a lot of educational aspects to it. You like to share a little bit about that. So I would assume that the material is also associated with the techniques that you follow or the methods that you use for 3D printing prototyping. What are the most common techniques and methods that you use at Makelab or that exist in 3D printing in general?
So we print in FDM and SLA currently at Makelab, but this upcoming month we're onboarding a couple more materials, which I'm really excited about, and which leads me to the most common, I think, in the entire 3D printing and additive manufacturing universe. I would actually say it's MJF, nylon parts. So
Okay.
MJF is multi-jet fusion. It's a technology created by HP. And so these are industrial units. The machines do cost hundreds of thousands of dollars. And so it's a multi-step process. Not everyone can do it. Not everyone can have a machine. Um, but it's powder based. And so if anyone who
Okay.
has 3D printed in FDM or SLA before, for anything that's an overhang or needs to be supported, you need to also print out support structures. And support structures support the geometries that like have an overhang of over, 45-degree angles, and they are what help the part print out successfully. But with powder, you're printing on a bed of powder, and so no supports are needed because the powder itself is what supports it. And so I would say that the nylon PA12 material that's printed off of the HP machine is probably the most widely used in the industry. It's become an industry standard.
And what is the benefit of actually going for this powder solution rather than the more sort of traditional, the ones that you currently use? What is the benefit of making that switch? Because it's more
It
costly, as you mentioned, but
it
what comes with it?
depends. It can be a little bit more costly. It slightly depends because the technology is different, it's priced different. So there's different factors. But um, one thing about it is precision. I think precision could be a
Mm-hmm.
little bit better, but generally speaking, compared to like FDM and SLA, precision on that nylon PI12 material is actually really great. And you don't have to worry about support structures. So engineers and designers, that's one less thing they have to factor in while they're designing. However, FDM is really, really great for quick and cheap. And so if
Okay.
you're and simple. And so if you're just printing something out to try something, PLA plastic is a really great material offered on our FDM machines and most FDM machines like anywhere. So it's also something we see often.
All right. And now you already mentioned that I mean, a very key difference is, for example, with the FTM, it is for sort of fast and cheap. You mentioned, right? How does a company decide if I was approaching you, Makelab, hey, I want to do some prototyping, how would you help me figure out which material and which technique do I have to follow for the best results for me?
So if you were to contact us and ask us like which material, we would first ask a few questions like, what are you using this for? What's your deadline? What's your budget? And like, what stage is this for? Like, are you just using it to see something and like test something out and then quickly move on to the next thing? Is this something that is going to be shown at a trade show or in someone, an important project stakeholders' hands? Um, what level of finish is expected? Is it expected that it's super smooth or is this just a rough draft? If it's just a rough draft, we say save your wallet, save your budget for later and go with the FDM because it's just simple, especially if the geometry, we also take a look at the part to see the complexity of the geometry. If it's something like we've printed a lot of jewelry pieces for like Audrey Rose and like Medjugorje. And so with them, I would never suggest FDM because they're printing pieces of jewelry that are so detailed. And so they need
Right.
something, they need resin SLA printed. And so it highly depends. We first look at the model, then we look at the other logistics of the project and the use cases.
Right. And what is the difference in terms of, I mean, how long does it take to complete a project or to complete, like a batch or something in FTM and in a resin SLA? Like, what's the difference between these two?
SLA has a little bit more processing involved, and so the support structures that are generated for like resin SLA prints are a little bit more intricate. And being that the models we normally get for that technology for resin SLA are more intricate, they need to be handled with more care.
Hmm.
So they take a little bit longer. So we do offer different lead times for both sets of technologies and materials. So FGM, we offer three 1, 2, 3, and 5 business days options. Whereas with resin, it's 3, 5, 7 business days.
Okay.
So we
Too
just allow
quick.
ourselves to, it's still quick, yeah. But it's just the bottleneck of the post-processing and support removal that we do in-house before we send out a part. That's what accounts for, the slight variance in
Mhm.
uh in timelines.
All right, thank you very much for that insight on these differences. Now, I want to scale a little up into the more general landscape of 3D printing, right? And one of the concerns that I find is actually pretty interesting, specifically in manufacturing, is in terms of durability, right? So
Mm.
for prototyping, that's not really a big issue because I would assume that like companies don't really use that a lot. In the end, it's for testing and stuff. But when it comes to actual pieces that are printed for maybe a final piece or a final device or somewhere along the supply chain, right? Or the production lane, how does a company ensure the reliability and durability of 3D printed products? What kind of materials come into place? What kind of maintenance come into place? How does that work?
Depending on the environment in which this product is going to live, that's what directly determines what material properties. And so if it's like a manufacturing, like the term end use can also be variable. Like, is it an end use piece that's going to be living on a manufacturing floor that's going to be changed out in a matter of months? Or is this like on the shelf? Because if it's on the shelf and it's going to be consumer facing, you're going to want it to look nice as well. And it needs to last. It needs to go through all the stress tests in the world. And so
Mm.
it probably, it's hard to name a material on the spot without exactly having that use case. But I would definitely start looking a little bit more industrial 3D printing. Um, industrial additive 3D, very
Right.
interchangeable terminologies. I would start there and then also look into treatments. So there are treatments to smooth out prints. They're like vapor smoothing prints. There are treatments to
Mm.
dye prints as well. Um, but for the manufacturing floor, like we do get a ton of like bulk orders where we're just printing jigs, like
Right.
grabbers or like placement, for labels, whatever it may be. That can be printed in PLA, it can be printed in, any of our resins that we offer. It's dependent upon what it calls for, really, and how long it needs to
Mhm.
last.
All right, okay. And actually, you mentioned something very quickly, which is that you don't really have like a material up top without an example. So let's say, for example, that this was a case, all right, for a company that comes to you that wants to do some prototyping and some testing in a medical device that is probably going to be directly in touch with maybe a patient or something. I'm not sure if you've already had a customer of the sorts, but what kind of process would that be specifically, and how would it differentiate, for example, with something like, I don't know, robotics, a prototype for
Mm,
robotics that is really not concerned with being maybe hazardous, or I don't know, how would that be
right.
different?
There are specific certifications you can get
Mm,
for your entire facility so that it's like uh skin so the end product is like skin safe or it's compatible.
mm,
Um and there's only I believe there's only a handful of materials that are actually biocompatible to begin with. So if you need biocompatible, you start with that handful and then you should probably get your whole facilities really certified as well because usually with additive and 3D, it's not a one-step process. It's like it comes out of the printer. It needs to be um, worked on a little bit more. It needs to enter like post-processing. So
mhm.
all of those machines should really be also biocompatible. So it gets really tricky with the bio. However, with robotics, you're probably looking at tensile strength a little bit more, impact resistance. You're probably looking at elongation at break a little bit more. And so
Mhm.
based on what your robot is doing and what part it is for the robot, that would directly determine what material properties you need,
Okay, so
you
basically, I
know?
would assume that there's already pretty much a list, I would say, of some sorts of materials that are maybe for biocompatibility or maybe listed by these mechanical properties that you already mentioned, right?
Hmm.
So I would assume that there's already a list for that. Can a company, maybe a small company, let's say the size of 10, 20, 30, maybe even employees, can a company really accommodate all of these materials into one place, or is it just far too complicated to do?
There's a level of complexity, but then there's a cost aspect as well. And
Mm,
so what we see a lot with our customers, I mean, our customers are like consumer and hardware brands. So it's very different than maybe the robotics companies. We do get some of those, but they work a little differently. So when it comes to the consumer and hardware brands, they usually do have a 3D printer or two or three in-house. But oftentimes during crunch time, like 3D printers aren't just a right click print type of thing. Like they need expertise, they need to be watched to some
right.
extent. Um, Sometimes, depending on what model you have. If the printer's down, you need to repair it. So those are hours of your team's time. So a lot of what we see is like people will start off with having a couple or three 3D printers, and then they kind of give up on it after a certain point. They're like, I don't have time for this. I need to be designing, I need to be developing, I need to be making decisions. So I'm just going to outsource the 3D printing. So and then if you think about if you get one machine, you're limited to the materials that are able to be printed on that machine. So I can't
Right.
just get a universal machine. It's like I can't get a laserjet paper printer and then print ink. Or print large format. You need a different
Right.
machine to do so. I need a plotter. If I want to do banners to print on glossy materials, vinyls, that's another machine. So it's very
Right.
similar to the 3D printing industry. You need multiple machines to retrieve the breadth of 3D
Yeah.
printing.
Actually, that is something that I personally overlooked it. You're totally right. The machines do these things differently. For example,
Yeah.
with these ink printing versus laser printing, I didn't really consider that. Now, For this, what is sort of the introductory machine for 3D printing besides the 3D printer that everybody sees in like college or that anybody can build out of Legos? What is that sort of introductory one?
I would say it's an FDM machine. A desktop FDM machine is probably the most introductory. If you're feeling a little bit more advanced and you have the proper setup, then you might go over to resin. And so
Mhm.
the FDM plastic printer machine is stop number one. Stop number two is resin SLA.
Okay, perfect. Well, thank you very much for that. Now, we've already covered a little bit about the materials, a little bit about the equipment. Now let's talk a little bit about the process at Makelab, right? So please walk us through the process of a company getting in here and asking you to prototype something using, for example, let's say with resin SLA, right? What would the
Sure.
process be for that?
Sure. So there's two ways to get an order in. So if you know what you're doing, you know what materials you want, and you have your 3D CAD file already, your STL file, you can just go onto our website. We have an instant quotation tool, and you could actually just place your order and self-checkout right from there. So I would say about 75% of our orders are done via this self-checkout journey.
Okay.
If you're in the 25% that wants more materials guidance, then you would submit an inquiry form or send an email. Our service team would get back to you and start, answering your technical questions, logistical questions, and guide you to the point where they're sending you an invoice, and then you pay the invoice and you place the order. So after you place an order, um, our production team downloads all your parts. They check the files for printability. So they're basically checking, is this printable? Is it printable in the material that you chose? And is it, can we print it in one piece? Sometimes files come in too large. We have to break them up or find another solution or change over materials. And then the last question is, can we do it on time? So we always
Mhm.
work by the deadlines. We find that's super important for any service, is that transparency of like when you as the customer is going to receive your part. That's like the number one thing that we need to guarantee as a
Right.
3D printing service. So when those three things, questions are answered, if any one is a no, if any one of those printability questions is a no, we place the order on hold and begin to engage with the customer again. Um,
Mhm.
but if it's all pass, then we slice it, meaning we throw it into each type of printer has its own program that tells the printer how to print that part.
Right.
So we throw the STL files, the parts into those programs, depending on the materials. We slice it and generate the code. And then
Mhm.
we schedule it, and when it's time to run, we send it to the printer.
All right. And for these software and programs that you mentioned you run, do you have any sort of proprietary software? Is there open source software for 3D printing or sort of like an enterprise one?
So to 3D print, it's if I'm buying a Formlabs machine, I'm using Formlabs software. There's
Hmm.
no other way around it. So
Okay.
there's no proprietary thing that we can create that can really, you know, not use them. Same with any other printer. They all have their own
Hmm.
proprietary because they are the manufacturers, and so you can't tell. It would be chaos if
Hmm.
I try to create something, not created the machine myself, and trying to tell it to do something that it ultimately can't do. So that's
Right.
like a huge risk. So they pretty much control that.
Okay. Okay. Yeah. Well, I would assume that yes, that everybody sort of has their own software based on the machine they use. It's good to know that it's actually from the machine sourced and nothing else. That's great. So thank you very much for that. Now I want to circle back to something you also mentioned, which is about these deadlines, which is about the fact that the most important part for you is that transparency, right?
Yeah.
How do you do it as the CEO? How do you juggle those deadlines with production, with supply chain, with procurement? How do you juggle all of this to make sure everything is on time, is on schedule, and doesn't drive the whole team crazy? How do you do it?
A lot of trial and error. I would say the first year and a half was pure chaos. And so that was like figuring out how far we could push things, what level of expectations need to be set with the customer, and trial by fire. It's really the first year and a half. But ultimately, we really set um, processes. We are such a process-oriented team. And so we like live and die by like our processes. So we have our own processes for inventory. We have our own processes for like machine maintenance. And all of this is to make sure we have the right stock in the lab at any given time. So we're not like delaying an order because we don't have material.
Mhm.
Um, Everything with machine maintenance, it's making sure that the machine doesn't fail and therefore, the print does, and the parts don't fail. And then in terms of the deadlines, we actually pretty much tried something out in 2019 where we set pre-made deadlines. So you can get things in 3 business days, 5 business days, 7, um,
Mhm.
2 and 1, and we priced accordingly. Um, so if you want something rushed, that's an extra charge.
Right.
And it has other parameters and policies around it. And so if you want something next day, it's really hard to mitigate risk for us at that point. So, when anything is super rushed, we don't remove supports. And if it fails, you've kind of printed it at risk. And so we had to put those things in place so that everyone knows kind of like what they're buying into. And so we also put cutoff times in place. So if you place an order, today before 3:30, which is 3:30 right now,
Yeah.
you'll get a confirmation of when your part is going to be ready for pickup, courier, or to be shipped. So you will after an order is placed, you will find that out within 4 hours. Unless it's after the cutoff, then it's the next business day.
Oh,
Um,
okay.
so it's like we operate as best as we can to those standards instead of being like, oh, when do you need your part? Oh, you need it by Friday. Joe, when do you need your part? And trying to juggle timelines that way, it's absolute chaos. And so there's already so many variables in any business, let alone something like ours. And
Yeah.
so the best we can to eliminate a lot of those variables is the key.
I honest to God don't really know. I cannot even imagine how you juggle. I just imagine the shop, like the floor on your company, going like, "Hey, I'm next because I have something for tomorrow." No, I'm next because I also have something for tomorrow. I kind of figure it that way, but I understand that you already figured it out amazingly, which is honestly pretty impressive. But now I wanted to continue down the line of this sort of a supply chain thing, and I want to go back to probably the worst supply chain time over the last few years, which is the pandemic, pretty much, right? In 2020, uh, there was a mess in supply chain in production, and I noticed that you at Makelab started developing a lot of personal protective equipment, or PPE, as it is called,
Yeah.
for the pandemic. Could you
Yeah.
please talk to us a little bit more about how you embraced this project, this building PPE with how did you juggle that supply chain as well? Who did you deliver it to? Could you just talk about us? Talk
Sure.
to us about that.
Well, I think there was an obvious slowdown in all of our revenue come like mid-March of that time. And
Yeah.
so because of that, I mean, as any business owner was, we were kind of like, crap, we need to think of something next. We cannot die during this period of time. And at the time we really thought it was so temporary as well. So there was that layer as well. So we saw that the community in general were releasing parts to produce like face shields and instruction manuals on how to produce face shields. And being that we do have a community, we do have a brand, we decided to jump on that bandwagon. Not only was it like helping um, everybody that we were giving face shields to and like the community, it was helping community contribute to their communities. It was also a brand new revenue stream that would last us and hold us over throughout that entire time of like lockdown and beyond. And
Hmm.
so we decided to just do it. I mean, it was kind of like we had to make a really quick decision. It was
Yeah.
uncomfortable. It was like me and Manny and I were just talking about it and we were weighing the pros and cons and we're like, well, I don't see why not, because the most we have to do is get the other materials to compile the face shield, like the acetate part. But everything else, a printer is a printer, right? We have the materials, we have the machine, we can easily, get the file printable and slice it, and then we throw it on the machine, and that part was easy. Um, and so our capacity was dwindling. I mean, our capacity was growing because of less revenue, less volume of orders.
Right.
So it's a sort of why not decision that ended up being like a lifeboat, really, for us.
I mean, that's actually pretty cool, the fact that it was a lifeboat. How did you come to decide which type of PPEs were you going to build, or sort of how would they accommodate with these certifications that you mentioned, making sure that they were fine to use pretty much for the situation?
PLA is a less of a risk. If you're using it just under like a consumer level, it's less you don't want to be using toxic materials that are rubbing against your skin.
Yeah.
But PLA is proven to not be that. Would I use
Mm,
PLA in you know, in a for a customer that needed something to be like biocompatible in a more scientific or lab setting? That's another story. But for
mm,
something like PPE, we felt it was okay. And a lot of the vibe of that time was also just try to help out.
yeah.
Um, they loosened a lot of the restrictions as well, which, could be a good thing, could be a bad thing. Depends how you look at it.
Yeah.
Um, so we just decided to go with it. And we saw an opportunity. We took it with the face shields. Then a company contacted us that was using iPhones to scan faces and create like mask fitters that would create a seal for the surgical masks. And so we jumped on that opportunity as well. And so
Hmm.
that's what really helped us survive through the really tough times.
All right, that's actually it's a very cool story. It's really honestly impressive. Now, I
Thanks.
want to go past that because there's so much more I want to talk to you about as a leader. One of these things that I wanted to mention actually is regarding some of the concerns that I've seen sort of started arising, involving 3D printing and additive manufacturing and all this, which is about environmental concerns, around waste, the energy that it takes for the manufacturing of these 3D printing, whole processes and materials. How do you address all of these concerns? How do you address sustainability at Makelab? And what is sort of the status of 3D printing and contamination, for example, and waste?
We do as much as we can. I think a lot of what we can do is really at the liberty of the machine manufacturers. And so if the machine
Hmm.
manufacturers aren't producing materials that are recyclable or or processes that are, that produce a lot of waste, it's our hands are kind of tied because we have to choose between the demands of the market and like what our customers know and what is doable in terms of sustainability. Internally, I can tell you that local pickup is probably the most prominent method of dispatch
Mm,
for our customers. These brands just they come in, they grab their parts, they say a quick hello. If they have time to chill, we'll give them some water, some coffee, something like that. And then they're on their way back to the office. So that accounts for most. I think opening up our doors to allow for that reduces our carbon footprint because we don't have to ship as much, we don't have to courier as much. We got rid of bubble wrap. We don't use plastic tape either.
okay.
And so small things like that is a lot of what we can do at the moment that are
Yeah.
directly our choice. Um, there is a new material that will be launching soon, hopefully, um, that actually has like 100% recyclable, um, like substrate material.
Right.
So it uses a material, it uses wax pretty much
Okay.
in the build process, in the technology process, and all of that wax can be recycled to use again in another build. And so all that you're wasting and can't all of that can't be recycled is the part itself.
Right.
So even at that point, it's considerably less waste than a lot of what else is out there, which we're really excited about. And it's a great material. So it kind of checked all the boxes for us.
Okay. All right. That's actually amazing. I did want to ask you precisely about how about recycling, for example, these materials. Now, going down that line, what are some of the materials that you would say were tried but definitely didn't work? Maybe because they were far too contaminant, maybe because they were maybe not useful for prototyping and whatnot. Uh, are there any that you would consider is like
Like
a definitely no go?
like recyclable or just in
Yeah,
general?
I would say that recyclable wise, like that they're just far too harmful or hazardous to really even consider them to add to your lineup, sort of on materials, if there are any.
Mm. Yeah, there's resins in general are not great.
Hmm.
The resin that we use off gases a lot less than a lot of the materials out there. I remember this one time we were looking and evaluating at other manufacturers for resin machines other than Formlabs. And what
Hmm.
we found, unfortunately, was that the resin that was being used, it gave us all headaches on day 2 of using it, which from one machine. And that is not good at all. And so we're like, if it's giving us headaches, it must be worse than what everything else we're using. So um, the off gassing is really important to us. I mean, worker safety, team safety is, I mean, I do not want to be the business that, produces health problems for their employees. So
Yeah, no. No, nobody wants to be that. And actually, that does raise a question for me. Now, when you're actually in floor, like in the trenches, really, what type of safety concerns do you have to take when working with these materials or with these printers or whatever?
so main thing for us at this moment is skin contact. And so you don't want to be
Okay.
like you don't want your fingers covered in resin. You want to wear gloves. You don't want to expose yourself in skin contact to resin in general. It's not great.
Okay.
These are highly, these are resins. So it's
Yeah.
it's not, any type of epoxy, any type of resin you really shouldn't be exposing yourself to too much, especially skin to skin contact. So you want to limit as much as you can. You want air filtration as well. And
Mm-hmm.
so those are a few of the things that we do.
All right. Well, now everybody knows that if they want to work with resin, wear gloves. That's very important.
Yes.
I personally, I mean, I understood the potential problems of resin, but not to the point where it could give you headaches the second day. I did not expect that, but thank you very much for that. Now, I want to
Yes.
go sort of start wrapping this up, right? Because I mean, we've talked about a lot of what you do, about materials, about some of the technical aspects to it. We've talked about a lot of this, which I find it amazing. However, I would like to get your opinion as the CEO, as the leader of an important company like Makelab. Where do you believe that the 3D printing industry is going towards? Are there any new technologies coming out? Maybe new equipments that are having the industry super hyped up? Any new materials that are definitely like gonna break the whole industry? Where is it going?
I think there's always something new in additive. The biggest question is it usable? Is it commercially viable?
Hmm.
So for me, a lot of the focus is not like the newness of it. It's like, great. That's great that you can print that newly flexible material, but how many times can I print it successfully and what is the yield rate? Those are the more important questions because you can have the whole breadth of material, but if of materials in the world, but if they only work 10% of the time in terms of printing, it's a complete waste of resources and budget. So I always, look at the more practical side of things. I've seen the hype cycles of additive, and I think one of the things that has hurt us in the industry is overhyping of newness and not really vetting what's possible.
Right.
Or really being specific about the use cases so people understand how and when they could use and leverage these technologies and materials. So I'm always excited when I hear validation, in the market about something, when I hear yield rates being validated, the one of the new materials that we'll be bringing on is close to like a 95 or even 100% yield rate, which, to be honest, having been in this industry for like 6, 7 years now, we were skeptical about until we saw it for ourselves, until we talked to more employees at this company, until we did our diligence, until we spoke to customers that were using this on their own. So it's, you know, that's more of what I'm excited about. And there's been so many announcements in this industry, and where have a lot of them gone is a really big question. I might get some pushback for this sentiment, but I think one thing that really hurts this industry is overhyping. So
Hmm.
yeah.
Well, Yeah, I mean, I understand why you would say that overhyping is it sort of hurts, right? Because then I would assume that a lot of investment in time and money goes into a material that might not actually be as useful as it was promised to be. I understand that. I understand that. It's sort of the same with reactives in the lab. So I mean, thank you very much for sharing that. It's actually pretty exciting. But now, I
Yes.
wa- I want to sort of start closing this out. Right, by first of all asking you something, which is before we started the interview, like live, you mentioned about your name pad over here.
Oh yeah.
How? I would assume that you printed that yourself, right? Like, why wouldn't you? so
Yeah.
so how fun can it actually really be working in a place with 3D printers all around you? What can you do that is actually fun with it? I assume you do. I honest to God, I assume you do a lot of that.
Yes. Yes. So this was made by one of our employees. We had an event that we were hosting and he surprised us, the whole team, with like all these prints, and he had to change out the filament for each color change. And so it was like a manual process, right? So that was like really great. Um, we love making internal tools. And so if you ever like visit and tour the lab, you'll see we have things from paper holders to tool holders and organizers. Um, just things that make our lives like a little bit easier while we're actually printing. Those things being 3D printed is awesome. And so we actually see some product development ourselves because we have to test multiple iterations before we start using it. And so that's pretty cool.
That's pretty cool. I mean, a typical company goes like, yeah, I mean, I need I don't know, a cup holder. Yeah, let's order it through Amazon. You're
Yeah.
like, no, we're gonna build it ourselves. That's actually pretty cool.
Yeah.
Hey, that's amazing. That's amazing, Christina. Thank you very much for that. Now,
Yeah.
before we move to the closure of this, I have one very last question, right? Which is, now you are the CEO of this company. You are the co-founder of this company, along with I believe you mentioned your husband Manny,
Yeah.
right? You've already been at this for quite a few years now, and you also have a lot of background in in other stuff like in engineering design and stuff. So my question to you is, what advice do you have for any person out there that might be starting their own path in entrepreneurship, in engineering, in 3D printing? What advice would you give to this person? Um,
Oh,
Christina?
hey. Yeah. Did I freeze?
Oh, yeah, you froze for a little second over there. Sorry, let me go back real quick. All right.
Okay.
I was just asking very briefly if you have any advice that you would give any young entrepreneur, engineer, person who's
Yeah.
starting their own path in 3D printing or just in entrepreneurship as a whole.
Yeah. So for the entrepreneurs who tend to be highly creative, big problem solvers, big strategic thinkers, like just big high level thinkers in general, I think one thing that entrepreneurs don't do enough, and this is like something I've heard, is really focus on the numbers. And so get
Mm,
good before you can hire a CFO. Like you're going to need to do that work yourself. So get very, very good with your forecasts, your projections. Don't
mm,
completely BS them. Understand your unit economics because it's a business for a reason. And
mm-hmm,
especially if you're going down the investment route, you don't want to be at a point where you're like, crap, I have 1 month of runway and I have to raise again in a month. Like I've heard that before. And that's really tough. That's a whole lot of pressure. So I always say just really take care of your cash and of your money. That's one. Um, Metrics and data are also key, and this one applies to everybody, whether you're in a job or whether you're doing your own thing. It's a really big way on how people get promotions if they can prove what they've done and the value that they've added. So metrics are key. Anything you can do to have those metrics for yourself, do it. Same with entrepreneurs and founders. You need to know where you came from, and one of the only quantitative ways you could do that is with your data and your metrics. So I'm all about the numbers in all senses. I think it's often overlooked because we get so excited about the product.
that's actually a pretty amazing advice. I have to say it. I believe that this advice is the perfect example of the mind of a CEO combined with the mind of an engineer. It's all about the data. It's all about the numbers. Thank you very much for sharing that. Now,
Yeah.
before we close this out, and meanwhile, everybody that is watching, they're gonna have the option to drop a question in the chat if they have any. In the meanwhile, they drop any of their questions. I wanted to thank you, Christina, before we go out of this, and I want to ask you two very quick questions about Makelab. Number one, what can we expect next? You already mentioned you're trying out a new material that is soon to launch, but do you have any exciting updates coming out soon? And number two, where can we find you? In the social media handles, your website? What's up with that?
So one of the new things that we're working on is a brand new website that has more materials for educational content, easier to navigate, cleaner, better UI, UX, usability, ratings, everything. So that's one big thing. The second one is the materials, like you mentioned. We will be thinking about other locations in the future. We're not ready for it yet, but they will. That is on the roadmap. And where can you find us? We're big on LinkedIn. And we're big on Instagram. And so if you just look for our 3D printed logo, I think our tag for Instagram is Makelab_3D. We're pretty active on there. We love our reels these days. The marketing team is really, really great. Shout out to them. And on LinkedIn, I think it's Makelab3D, no underscore.
All right, perfect. Yes, you are very active on LinkedIn. That's pretty much where I learned most of everything that I know about you as for this point. It's amazing. It's super insightful. So thank you very much for that. It appears that there are no questions as of this moment, but no worries, because everybody, please go follow Makelab on social media, LinkedIn, Instagram. I can vouch that you put actually a lot of really interesting info there. So do go ahead and check them out. I believe this is the perfect way to give a closure to this interview. Thank you very much, Christina, for being with us today. And to everybody out there, remember, you can find more information, interesting articles, and interviews directly on our website, controlhub.com/builder-nation. We're going to love to hear from you. Thank you again for being part of this community. We're going to see you the next episode. And Christina, thank you very much for being the first one to ride along with us on this brand new format we're following. I believe it was amazing. Thank you very much for your insights.
Thank you. Thanks for having me. This was great.
Thank you very much. And everybody out there, thank you very much. We're going to see you on the next.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the ControlHub way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via ControlHub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic three-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. ControlHub. Get back to building.